Hi everyone, this is Dr. J. Ravindranath Reddy, working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. So we are discussing the numerical methods and integral transform course. In that course, we are discussing the Laplace transform. So in that Laplace transform, we are taking change of scale property here. Change of scale property. So in this video, we are discussing the change of scale property of Laplace transform. So first we will take the statement of change of scale property when we can apply the change of scale property for the given function. So L of f of t is equal to f bar of s. So already we have seen. Then whenever the function is in the form of like f of at, like f of 3t, f of 2t, f of 5t, if you have that type of functions, then if you want to apply the Laplace transform for this, we have L of Laplace transform of f of at is equal to 1 by a into f bar of s by a. So 1 by a into f bar of s by a. So if a is multiplied with t, then in the RHS side that a becomes in the denominator 1 by a into f bar of s by a. Now we'll see how to prove this condition. So as usual, take the definition of Laplace transform. L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. Now replace f of t with f of at here in this definition. So Laplace transform of f of at is equal to integral 0 to infinity e power minus st into f of at into dt. Now apply the substitution method. So replace f of put at is equal to u. So then apply the derivative on both sides. You will get dt is equal to du by a. Here a is constant here. Here a is constant. Now here what I am doing is I want to apply the substitution method to get this integral value. So for that what I am doing is I want to replace that at with new variable u. So that's why I have taken at is equal to u. So apply the derivative on both sides. Here a is constant, so a into derivative of t is dt is equal to du. So we want only dt. So take dt is equal to du by a. Now since this integral limits 0 to infinity, this limits belongs to t, but we are replacing that t in terms of new variable u. Now depending upon this t limits here, I want to get the limits of u. So when t is equal to 0 or when t is equal to infinity, put t is equal to infinity here. Infinity into something is equal to infinity. So you will get u value is also equal to infinity. Now take the lower limit of t. Our lower limit of t is equal to 0. Then replace t equal to 0 here. 0 into anything equal to 0, you will get u value is also equal to 0. So even though if you replace t variable, if you convert the t variable in terms of new variable u, we are not affecting that limits of that integration. In both cases, we are having the same integral limits, that is 0 to infinity. So now take this. So therefore Laplace transform of f of at. So here I am applying the substitution for this. So integral 0 to infinity e power minus s into t. So here we have taken at is equal to u. So from this t is equal to u by a. So here in place of t, I have replaced u by a. U by a into s, you will get su by a. F of u, f of at is replaced with f of u into dt. We got that dt is equal to du by a. Now a is constant, so we can take that a outside here. So this is equal to 1 by a into integral 0 to infinity e power, so 1 by a into integral 0 to infinity e power minus s by a into u into f of u du. Now this is equal to 1 by a into, so here the definition of this Laplace transform we have taken e power minus st into integral 0 to infinity e power minus st into f of t. So this integral you can write it as f bar of s, but here in place of s, here we are having s minus a, so this entire value we can consider as f bar of s by a. So this is our change of scale property here. And similarly we have another one. So in the previous we have taken the Laplace transform f of at whenever that a is multiplied with t, whenever the function is f of at, then we have taken this value as 1 by a into f bar of s by a. Now instead of multiplying this a, suppose if you divide the t with a like this, f of t by a, whenever we are having these type of functions, then if you want to find out the Laplace transform, reverse. Here in the LHS side we are having the denominator as a, so you multiply that a here, a into f bar of as. So instead of writing in the new denominator whatever this formula we have taken in the previous, just multiply that a here, a into f bar of as. Instead of taking s by a, here we are taking as. Okay, this is another next one, change of scale property, another property here in the change of scale. This is the second one. Now let us take the example where we can apply this change of scale property here. So already he has given f of t, Laplace transform of f of t is equal to some value. Now you take the help of that value and we have to prove this value here. Laplace transform of e power minus t into f of 3t. We have to prove this value is equal to this value here. Okay. Now once if you observe this, in the previous slide we have taken, if any function is multiplied with some other exponential function, then first we have to find out the Laplace transform of that function, which is by neglecting that exponential function, and then we have to go for the first shifting theorem. Follow the same procedure here. So f of t, this is the given condition, Laplace transform of f of t is equal to this 1 by s into e power minus 1 by s. You consider this entire value as f bar of s here. Okay. Now first one by one, first we will find out the Laplace transform of f of 3t and then we can go for the first shifting theorem here. So now by using change of scale property, I want to find out this is our formula. Why I am using this formula? Because t is multiplied with some constant. So this is of the form f of at. So f of 3t is in the form of f of at. So I have chosen this formula to find out the Laplace transform of f of 3t. So now f of 3t is equal to Laplace transform of f of 3t. You compare this and get the value of a. So in place of a, here we are having 3. So in this standard formula replace a with 3. So you will get 1 by a into f bar of s by 3. So 1 by a replace with 3. We will get this one. Now we don't want this only f of 3t. This f of 3t is multiplied with some exponential function e power minus t. So if you want to find out the Laplace transform of this entire function, e power minus t into f of 3t. So now already in the previous class we have seen, if any function is multiplied with exponential function, then we have to take the help of first shifting property. Okay. So now f bar of, so now here f bar of s by 3. So already we know the value of f bar of s which is given in the problem. Use that problem, f bar of s value. Here we want f bar of s by 3. So replace s with s by 3. so 1 by 3. F bar of s, 1 by s, we have to replace s with s by 3, so 1 by s by 3 into e power minus 1 by s, replace s with s by 3 here. So 1 by 3 into 1 by s by 3, this can be written as s3 by s into, similarly e power 1 by s by 3 can be written as e power minus 3 by s. This 3 gets cancelled. You will get this value is equal to 1 by s into e power minus 3s, e power minus 3 by s. This is the value of Laplace transform of f of 3t. So now the problem is not completed because f of 3t is multiplied with this exponential function. So now in order to get this entire Laplace transform value, then we have to take the help of this first shifting theorem. The beginning only in the previous video we said that if any function is multiplied with exponential function, then we have to take the help of this first shifting theorem here. So Laplace transform of f of Laplace transform of e power minus t into f of 3t. So how to use the first shifting theorem? Neglect this exponential function and consider the remaining function. For that remaining function, you find out the Laplace transform and then replace s with s plus a. So here we are having a negative power, so keep positive, and the coefficient of t is 1, so 1 here. So already we got Laplace transform of f of 3t. So replace that value here, 1 by s into e power minus 3 by s, and replace s with s plus 1. So 1 by s, replace s with s plus 1. E power minus 3 by s, replace s with s plus 1. Then we can get our required value here. So this is the way how we can apply the change of scale property in the Laplace transform here. So in the next video, we are going to study about the Laplace transform of derivatives. So how to find out the Laplace transform for the derivative functions like f dash of t, f double dash of t, or f triple dash of t, and so on. And similarly, how to find out the Laplace transform for the integrals. Inside the Laplace, if you have an integral function, then how can you find out that Laplace transform? These two topics we are going to discuss in the next video. Thank you.